To continue on our discussion of how to statistically represent your chance of getting a particular trait, we are going to work with monohybrid cross, which means we're going to work with one trait. This can get pretty complicated pretty fast. We're not going to do very complicated crosses because at some point we need to actually move on to our last unit. Oh, Friday, we talked about genotype and phenotype. So genotype are letters that we use to represent the alleles that you inherit from mom and dad. There will always be two because you have two genetic contributions. Phenotype is what the person looks like because they get these traits. So Gregor Mendel was a monk who played with peas. He lived in Austria, which is in Central Europe, and his idea was that if you crossed a yellow pea and a green pea, there was a reason why you would end up with yellow peas in your first generation or filial generation. And then if you took two of those yellow peas and crossed them, in the second generation, you would end up having a mixture of green and yellow peas. So what he sought to do was to try to figure out why this was happening. He called the inheritance of a particular characteristic a factor. Back in his time, we didn't know about DNA. Okay. So a yellow pea is dominant to a green pea. The only way a plant can have a green pea is if it has two recessive alleles which code for the green color. If you have a purebred homozygous yellow pea, which means dominant alleles for both of them, the pea will be yellow. Any hypotheses as to why crossing these two peas would result in pealets, baby peas, that were all yellow? What do you think, Sylvan?
Because you would need to have two little y's for it to be a green one.
Okay.
I didn't hear the question, but this is my guess.
So these are parent peas. They're going to pass on a Y to their offspring. So imagine if this was passed on, and if this was passed on.
So the y, if there's a big y at all, it'll be a yellow, right?
Mm-hmm.
That's why I said it. But like in my own way.
All the offspring would be yellow because they would have one dominant allele. That dominant allele would overrule the recessive green gene. Next question. If I take one heterozygous yellow pea and cross it with another heterozygous pea plant, why do I get yellow and green pea plants?
Wait, what?
Well, it depends which one they pair with.
Exactly. Exactly. And that's what Mendel discovered, is that because you could pass on this or this, well, then if the offspring got big Y, it's going to be a yellow pea plant. If the offspring inherits a big Y and a little y, still yellow. But there's the opportunity that the pea plant will inherit two recessive Y's alleles from the parent. What is the chance of having a baby pea plant out of this cross here that is green? Any predictions? What do you think the chances of having a green pea offspring?
50%? It's a 25% chance.
You're right.
For
Why?
Because you could have one Y and then you have like a 50% chance of having one big Y.
Because you gotta foil it.
Because you gotta boil it.
What do you think?
Now, there's two different combinations of big Y and little y.
Yes.
Hey, I'm speaking, thanks. Two big, okay, because there's only one combination where it's two Ys. There's the big Y.
Mm-hmm.